Hello and welcome to the 2020 Skywarn Spotter Presentation. Thank you so much for your interest in the Skywarn program. This is the recorded version, recorded in October of 2020. No worries if you are watching this at a later date. The presentation changes very little from year to year, just a few things here and there based on your feedback, but most of the critical information remains the same. So what is Skywarn? Well, again, thank you for your interest in the program. This is a program that has been around since the 1960s. It is a program for volunteer weather enthusiasts. We are hoping that you will be interested to safely identify and effectively report adverse weather near your location. We are not asking you to storm chase. You can just report the weather that you see at your own location. This is not a storm chasing class, and we really want to emphasize safety, weather safety, and keeping you all safe as well. So it's an opportunity for you to help us in our forecasts and in our watches and warnings in being our eyes on the ground across the area. So to become a Skywarn spotter, you first have to complete this class. So watch this full recording, have access to a telephone, internet, or be a ham radio operator. And at the end of this class, when you submit your registration, you will get a spotter ID. And with that spotter ID, you will also get information on how to send us your reports via phone, email, social media, or ham radio. If you are interested in becoming a spotter, as I mentioned, you will register to get your spotter ID. You don't have to register to get a spotter ID. If you're not interested in becoming the spotter, that's fine. You're welcome to view this recording without becoming a spotter. If you do register to get your spotter ID, just know it may take me up to 4 weeks to get the spotter ID to you. If you do live outside of the area that our office covers, please send me an email at sarah.johnson@noaa.gov. That is sarah.johnson@noaa.gov. And I will put you in touch with your local National Weather Service office. So before we get into more about the spotter program, we'll first talk about the National Weather Service and who we are. We are a part of the federal government under the Department of Commerce and the National Oceanic and Atmospheric Administration. We provide weather, water, and climate data forecasts and warnings for the protection of life and property and the enhancement of the national economy. That is straight from our mission statement. We have several national centers, regional centers, and then what we call weather forecast offices. These are our local offices. Our office here in Mount Holly, New Jersey is one of 122 across the country, covering all 50 states and U.S. territories. Here is a look at our office. This is a look at our operations floor of our office. When we are fully staffed, we have 25 people at our office. Because the weather is always happening, we have at least 2 to 3 people on shift at all times. So 24/7, 365 days a year. Here's the area that we cover. We cover most of New Jersey with the exception of 5 counties in northeastern New Jersey. We cover all of Delaware. We cover 5 counties in northeastern Maryland. However, I need to put a caveat here. If you're watching this presentation after November 10th of 2020, Cecil County, Maryland is actually going to be a part of the our sister office, WFO Sterling, Virginia. They will be taking over forecast and warning responsibilities for Cecil County. So this will be changing here shortly, but up until November 10th, Cecil County in far northeastern Maryland is part of our county warning area. And again, November 10th, that goes over to Sterling. And then we also cover much of southeastern Pennsylvania, including Philadelphia, Allentown, on up into the southern Poconos. If you're not already familiar, we have a website. Weather.gov is the website for National Weather Service across the country. And then if you go to weather.gov/PHI, that'll take you directly to our office webpage. Talk a little bit about some of the products that we issue. I'm sure many of you are familiar with watches and warnings, be it a winter storm watch or a hurricane warning or a severe thunderstorm warning. This just kind of gives you an overview of when we issue each product and what kind of detail we're looking at. So up to a week ahead of an event, be it a winter storm or severe thunderstorms, we may include a mention of potential hazardous weather in what we call our hazardous weather outlook. This provides a single source of general information for any kind of weather hazards for the next 7 days. If something is in here, it does not necessarily mean that we have a lot of confidence that it will occur, but it's possible and we are watching it. When we get a little closer to the event, up to 2 days ahead of time for winter weather, flooding, and tropical hazards, up to just several hours ahead of a severe thunderstorm or tornado event, we may issue a watch. This watch means conditions are or will become favorable for hazardous weather warning criteria to be met. So, for example, a winter storm watch, that just means that sometime within the next 48 hours, there is potential for a winter storm warning criteria to be met, but we're still not sure about the details, like where the heaviest snow may occur or how much of an extent there will be of the heaviest snow. When the hazardous condition is imminent or already occurring, then we'll issue either an advisory or a warning. An advisory means that hazardous weather is occurring, but we're not quite reaching warning criteria. And a warning means that hazardous weather is occurring or is imminent, and we are reaching warning criteria. Switching gears now, we'll talk a little bit about some of the tools we use and why it's so important for us to also have spotters in our area and to have those eyes on the ground. So first, specifically, we're going to be looking at radar. And radar is a wonderful tool. It's been a big leap forward in meteorology. Without it, we couldn't do nearly as much as we can especially with severe thunderstorms, tornado detection, and tropical weather. So weather radars, the main weather radars that we look at are called WSR 88Ds. The WSR just stands for Weather Surveillance Radar, and the 88P means it was commissioned in 1988. And it has Doppler capability. That's what the D stands for. There are two in our region. One is near Fort Dix in Ocean County, and one is in northern Sussex County, Delaware. And you can see the pictures there on the screen are from the K-Dix radar in Ocean County. It is a very large piece of equipment. The dish that you can see on the right-hand side there is 28 feet in diameter. That is all encased in what we call a radome. the white golf ball there. You can see on the left-hand side. And that is, ironically enough, to protect it from the weather. Because the dish has an open face, it could easily be toppled by strong winds. So we encase it in the in the radome to protect the dish. As wonderful as a tool as radar is, it does have some limitations. It has poorer resolution the further away you get from the radar. Full scan can take anywhere from 4 to 10 minutes, and in the life of a severe thunderstorm, and especially in tornadoes and in downbursts, that can miss an entire development of a brief tornado, entire progression of a microburst. So that can be a long time. In addition, another limitation of the radar is that it is scanning within the storm cloud, which is good. It's an important thing for us to see, but at the same time, a lot of what we're really interested in is happening below the radar beam. And this is for two reasons. Number one, the lowest radar scan happens at 0.5 degrees above the horizontal, so it's already slightly elevated. But also due to the curvature of the Earth, the further you get from the radar, the higher up even that lowest slice goes. So that's why spotters are so important, because we, as you can see in this kind of stylized example here, we really want to know what's happening in that red box. But we can infer, based on what the radar is sampling, what may be happening. But without some ground truth and getting reports from spotters, we may not know for sure what is happening on the ground. So why we need spotters, as I just mentioned, it's very critical to get the ground truth, to know exactly what is happening, and to fill in the gaps of where the radar has limitations. And as I kind of mentioned before, we have, especially in our area, we have a very high percentage of weak tornadoes. It's a lot less defined on radar, and can be briefer. So it's a lot harder to warn for those just based on radar data. Getting the real-time verification, we can also add that information into our warnings. That will enhance public response, and also helps us to know if you're getting quarter-size hail at your location and suddenly the storm looks like it's strengthening, then that helps us to know that maybe larger hail is about to occur. So that's a little bit about the Skywarn program and radar. Now we're going to get into kind of the heart of the presentation, which we're looking at specific weather hazards, staying safe with those weather hazards, and also what we're looking for you all to report to us. So first and foremost, we're going to be talking about thunderstorms. It is a process that takes heat and moisture near the Earth's surface and transports it through the atmosphere. At any given time, around 2,000 thunderstorms are occurring across the globe. But of those 2,000 thunderstorms on average, only about 1% are considered severe. And of that 1%, only a very small fraction of the severe thunderstorms produce tornadoes. So a very small percentage of thunderstorms are severe, and a much smaller percentage of those actually produce tornadoes. So before we get into the life cycle of thunderstorms, what are we looking for when we're forecasting thunderstorms? There are three main ingredients that you have to have in order to have thunderstorms. Number one, moisture, obviously, just to have to have any clouds develop and to have any precipitation develop, you have to have some sort of moisture, preferably in the lower and mid levels of the atmosphere. It's critical for thunderstorm development. Second, you have to have instability. This is a fancy way of saying that air will continue rising after initial push because of differences between the temperature inside the air parcel and the temperature of the environment around it. And finally, you need a source of lift, something to give it that initial push. In our area, I've listed 4 of the more common sources of lift. Cold fronts, very common source of lift for thunderstorms around here. Land and sea breezes. Sea breezes, especially in the summertime, those are the line of thunderstorms or line of showers or thunderstorms you may see develop in a line near the coast and then kind of move inwards on a warm summer afternoon into summer evening. Elevation effects, sometimes you can get air that is forced up over ridge lines. So in our area, when you get into the Piedmont and into the further west into the southern Poconos, if the wind is moving in a certain direction, it can be forced to go up over the ridge lines, and that can be a source of lift. And then differential heating, that is a fancy way of saying if you have a batch of clouds over one area and right next to it is bright sunshine, there is going to be a difference in the temperature in the area in the bright sunshine versus the area that is overcast. And along that line, we call that a differential heating boundary. 2 terms to define with thunderstorms. Thunderstorms are composed of updrafts and downdrafts. Updraft is just a fancy way of saying where air is moving upwards in the thunderstorm. An updraft is characterized by a very distinct edge to the cloud. It often has this cauliflower appearance that you can see now in this picture. You typically don't see a lot of precipitation under the updraft. The downdraft, on the other hand, is where you do see a lot of the precipitation. It tends to have a blurry or streaky appearance. So in the example here, to the right-hand side, you can see a very distinct cauliflower appearance. That is the updraft. And then as you get about halfway across that image, you can see it's really hard to see where the bottom of the cloud is. The cloud itself has not as well-defined top to it, and that is where the downdraft is. The life cycle of a thunderstorm starts off with the developing stage. As the thunderstorm is developing, it only has an updraft. It does not yet have a downdraft, typically. So you may, when it first starts to develop, it may not have any precipitation at all. As precipitation does begin to develop, a downdraft is formed. In this stage, we typically aren't as concerned about severe thunderstorm hazards. This stage is usually relatively benign, although you can have lightning in this stage, and we'll talk more about that in a minute. That can be hazardous, obviously, but we don't warn for lightning. We'll talk more about that in a minute. Here's a real-life example. You can see the thunderstorm clouds are just starting to bubble up, but we're not really seeing much evidence of that streaky or blurry appearance. So we know there has a downdraft hasn't developed yet. So this is still in the developing stage. Mature stage, this means that both an updraft and a downdraft are present. This can be, in this stage, we can see severe thunderstorms, but again, only a small percentage of thunderstorms are severe. and all thunderstorms will go through this stage. So just because the storm is in a mature stage does not necessarily mean that it is severe. Here is a real life example. Again, you can see very clearly kind of at the front of this picture, the cloud has a very distinctive edge indicating the updraft. And then as you kind of see in the background, it gets a little harder to see where the bottom of the cloud is. So that would be where the downdraft is, and that's where the heavy rain is falling. And then finally, we get to a dissipating stage. This is where the storm is dominated by the downdraft. There is little, if any, updraft anymore. Just because the storm is dissipating at this point does not mean if it was severe, it could still be severe. And in fact, you can still get very strong winds in the dissipating stage. And here's an example, again, from real life. You can see pretty much the entire cloud has that kind of streaky, blurry appearance, very little definition, indicating that it is pretty much all downdraft at this point. So as I mentioned, we're most concerned with the mature and dissipating stages when we're talking about severe thunderstorms. So what is the criteria for us to consider a thunderstorm a severe thunderstorm? For that to happen, it has to have one of three things, or a combination of these three. It has to have winds of 58 miles per hour or higher. 58 sounds like kind of an arbitrary number, but it relates to 50 knots or 50 nautical miles per hour. And it's also the point at which we start to see property damage and more significant tree damage. You can have damage to trampolines and small limb and branch damage at winds below 58 miles per hour, but typically when we get to 58 miles per hour, we're looking at a little bit more tree damage and most property damage. Hail of 1 inch in diameter or larger, that is about the size of a quarter. And again, why we consider 1 inch to be the standard for severe hail is because that's typically the size at which you start to see any potential for damage, either to cars or to roofs. Typically don't see damage with hailstones smaller than that unless they are wind driven. And obviously any storm that produces a tornado would be considered severe. So this is probably our most popular topic in the Skywarn presentation. We're going to talk in depth now about tornadoes. So what is a tornado? The official definition: violently rotating column of air, pendant from a thunderstorm cloud and in contact with the ground. So that is to say that the rotation has to be connected both to the main thunderstorm cloud as well as the ground. Even though the rotation is in contact with both of those, you may not see that distinct condensation funnel all the way down to the ground. We'll talk more about that in a minute. In our area, it is more common to have tornadoes in the spring and summer months, but it can occur any time of the year. It is rated based on the enhanced Fujita scale, and we'll go into that in a little more detail in a minute. Most of the tornadoes, vast majority of the tornadoes in our area are either EF0 or EF1. This is a real-life example, but as you might be able to tell from the surrounding landscape, this is not from our region. This is actually from the Midwest. And tornadoes tend to be a little more visible out there. They have less trees. So a lot of our examples that we use in this presentation come from the Midwest, just because when we're first teaching you about tornadoes, it's easier to show you more distinctive tornadoes than the type of tornadoes that we have. This is a case where you can see the condensation funnel clearly from all the way from the cloud all the way down to the ground. Here is another photo, again courtesy of the same photographer as the last one, Lynette Evans. It's a little harder to see, but you can see this condensation funnel to the left of the main rainbow, and you could kind of see it's on. You can kind of see these double rainbow to the left of that. It's a little hard to see, so depending on your display, you may not be able to see it. Here is an example from our region that was pretty easy to see comparatively for the tornadoes that we have. This is from 2001 in Summers Point, New Jersey, and you can see the condensation funnel. You can't see it all the way down to the ground in this case, but it was determined after the fact that it did cause damage at the ground. Ingredients for tornadoes, the same as the ingredients for the thunderstorms. You still need moisture, you still need a source of lift, and you still need instability. But there's a fourth ingredient that you need for tornadoes, and that is something called wind shear. And you need a very specific type of wind shear. Wind shear is a fancy way to say that winds are blowing in different directions at different speeds at different levels in the atmosphere. And you need that wind shear in a specific configuration to create the rotation. So a few more definitions. A funnel cloud is a violently rotating column of air attached to the main cloud but not in contact with the ground. So this should sound very familiar to the definition of a tornado, and that's because a funnel cloud, very close to a tornado, is just that rotating column of air that is not yet in contact with the ground. A funnel cloud can become a tornado, and certainly a tornado can lift and become a funnel cloud, but a funnel cloud itself is not in contact with the ground. As with the tornado, the funnel cloud also develops in the updraft region of the storm. So here is an example. You can see the condensation funnel goes down from the ground, goes down from the cloud, but stops about halfway down. And there is no evidence at the bottom of any debris being picked up on the ground. So this was just a funnel cloud. A water spout, very easy. The definition for this, it is just a tornado that is occurring over water. This was a photo from Belmar, New Jersey, from several years ago. Wall cloud. You've probably heard this terminology. What it means is a local, often abrupt lowering from a cumulonimbus, which just means a thunderstorm cloud base. In this image on the right-hand side, you can see this area kind of in the center of the image that is lower than the rest of the cloud base. And that is a wall cloud. It marks the lower portion of a strong updraft. So as with the funnel cloud and a tornado, this will occur in the updraft region of the storm. Lots of thunderstorms have wall clouds, but again, a very small percentage of them produce tornadoes. So just the presence of a wall cloud does not necessarily mean that the storm is about to produce a tornado. However, there are a few warning signs you can look for. If it is significantly rotating, or if it's been very persistent for a long time, and you can see evidence of rapidly rising motion That is to say other clouds, what we call scud clouds, which we'll talk about in a minute, are rapidly moving into the wall cloud, then those can be some warning signs. But again, a lot of thunderstorms have wall clouds that don't even produce a funnel cloud or a tornado. Okay, scud cloud. These are very scary looking clouds, but are harmless. They can occur either with the updraft or downdraft. The big distinction with them is that they will not be rotating. So in this case, both examples in this picture look like you have two funnel clouds. And it's hard to see in a still image, but if we were to play a video of this, neither appendage from the bottom of this storm is rotating. It is in fact just scud clouds. It is in the updraft of the storm, so this is moist air moving up into the storm. And in fact, that one on the left-hand side that looks really ominous, very wide, it's actually, as the storm is moving over a lake, it is pulling up moisture from the lake into the cloud. Very scary looking, but is harmless. However, as I mentioned, they can be good indicators of the airflow around a thunderstorm. Here's another example. Again, very ominous looking storms. In this case, you have the two on the left here are in the area of the updraft of the thunderstorm, and the two on the right here are in the downdraft area of the thunderstorm. So another example of scud clouds that can occur either with the updraft or the downdraft. So now that we've gone through some basic definitions, going to have a little quiz here. What do you think this image is depicting? This little portion right here that I'm circling with my pointer, kind of in the center of the image. That is actually a tornado. This is more common in our area where it's very difficult to see a tornado until it is very close to you. And in fact, this truck was up on an access road on the top of a hill in Carbon County. When they saw this, fortunately, the person that took this picture jumped in the truck and got down off that access road very quickly, which was good because this tornado came through this very area just several seconds later and caused considerable tree damage on that access road. This is from October 2nd, 2018. We had one tornado that day. We had one tornado in Carbon County and one tornado in neighboring Monroe County, and several tornadoes further west in Pennsylvania. It was the largest October tornado outbreak in Pennsylvania. So how to stay safe in a tornado? In order to stay safe in a tornado, you first step is to get to the lowest floor available to you. If this is a basement, that's great. If you don't have a basement, going to the first floor, or again the lowest floor that is available to you, works as well. Get to an interior room on that lowest floor. You want to try to avoid any rooms with windows. You want to try to put as many walls between yourself and the outside as possible. And the reason we say this, look at this image of this house on the right-hand side here. This is the before picture. Here's the after picture. As you can see, even if you were up on the second floor, if you were in an interior room, many of those walls are still standing. Exterior walls are not. Obviously, the ideal situation would be to be on the ground floor. As you can see, almost all of those walls are still standing. What to do if you're not at home? If you're in an office building, hotel, or shopping mall, Any place that is open to the public should have a designated tornado shelter, and it's important to know where those are, especially if it's someplace you frequent a lot, like your office. It's important to know where those are before severe weather strikes, so you know what to do if a tornado warning is issued. If you're in a mobile home, that is not a safe place to be during a tornado. It's very important, if you're in a mobile home, you have a severe weather plan in place to know where the nearest shelter or sturdier building is where you can take shelter. Vehicles are not safe in tornadoes. Much like mobile homes, that is not a safe option to ride out a tornado. So this is the enhanced Fujita ranking. As I mentioned earlier, the vast majority of tornadoes, both in our area and actually vast majority of tornadoes across the world, are on the lower end of the scale, the lowest two categories, EF0 and EF1. EF2s and EF3s, we have seen actually both EF2s and EF3s in the past 2 years in our area. We've had a very active severe weather year both in 2019 and again in this year in 2020. EF4s and EF5s are very rare. Less than 1% of all tornadoes across the world. Extremely rare in our area. They can be long-lived and cause considerable damage and account for over 2/3 of tornado fatalities. So now we're going to shift gears and talk about straight line winds. Straight line wind is just strong wind that is associated with a thunderstorm but is not rotating. That is not associated with a tornado. In our area, straight line winds can do just as much damage, if not more damage, than tornadoes. You can have winds that can exceed 100 miles per hour. And if we go back to the tornado scale, you can see tornadoes that exceed 100 miles per hour are at least an EF1, if not higher. So these can do just as much damage as tornadoes. And with straight line winds, you often see these over a much larger area than you do as compared to tornadoes. So that's why they can do more damage in many cases than tornadoes in our area. In the image down here is in the lower right corner is from a downburst in 2019 in Lower Frederick Township, Pennsylvania. Winds were 110 miles per hour. So again, that's kind of on the cusp. If it was a tornado, it would be on the cusp of an EF1 to EF2. But this was all straight line winds. No tornado occurred with this. You may have heard of the terms downburst, macroburst, or microburst. We'll talk more about exactly what a downburst is in a minute, but those are all terms that are interrelated. Microburst and macroburst is a downburst. Those are both downbursts, but it just depends on how much area the damage covers. If it covers less than 4 kilometers, then it is a microburst. If the damage covers greater than 4 kilometers, then it is a macroburst. You may have heard the term too, squall line, or quasi-linear convective system, or QLCS. All three of those terms are just a fancy way to say storms that are in a line, a linear-oriented group of storms. And so let's talk about downburst first. Downburst is where somewhere in the thunderstorm, either in the low levels below the cloud base, or more common in our area in the mid-levels, dry air is being engulfed in the thunderstorm, and that causes the precipitation to evaporate, and that causes that air parcel to cool very quickly, and so it starts to accelerate downwards towards the ground. When it gets to the ground, it has to go somewhere, and so it spreads out, and you will often see downburst, microburst, macroburst, damage path from those. Looks like it's a fanned out damage path. We'll show an example of that here in a minute. In the lower right corner, that is a real life example. You can see the brain shaft kind of looks like it has a foot on it. It looks like it's pointing out towards the right hand side. That is indicative of a downburst, where it was portion of a blob of rain was accelerating towards the ground, got to the ground, and it had to go somewhere, so it spread out. All right, squall lines, also known as quasi-linear convective systems, or QLCS, mentioned is just a linear complex of storms. Not all squall lines are severe. It is very common phenomenon in our area to see squall lines or QLCS. We get several of these a year. They can be accompanied by a shelf cloud, as the example here from August 28th. This was in Cecil County. If they start to appear to be bowing out on radar, that can be a warning sign of severe winds, severe straight line winds. You've probably also heard the term derecho, especially if you were living in our area in 2012. That was kind of the hallmark derecho event until this year. A derecho is a squall line or QLCS, but it is a particularly long-lived and widespread subset of squall lines. The official definition, the swath of wind damage extends for more than 650 kilometers, which is about 400 miles, with the width of approximately 100 kilometers. Some notable recent derechos. Just a few months ago, August 10th, 2020, you may have heard about the Iowa derecho, as it's commonly called. It actually affected several other areas. As you can see there listed all the states that were affected by this derecho, starting in Nebraska. Iowa was particularly hard hit. Illinois, Wisconsin, Indiana, Ohio, and Michigan. And that is actually on the left-hand side here. Those are all the storm reports from that day. Not all these storm reports are related to the derecho, but as you can see, this kind of swath of storm reports that starts in eastern Nebraska and continues east. That is a part of that derecho. We had a derecho here this year, June 2nd through the 3rd. The impacts in our area occurred on June 3rd, and we'll talk more about that in a minute. And then, as I mentioned before, kind of the hallmark derecho event was June 29th through the 30th, 2012. The storm reports for that event are over here on the right-hand side. This derecho started off in Iowa and eventually moved offshore over the mid-Atlantic. So as mentioned, we did have a derecho this year. It started off June 2nd in the Midwest, and by the time it got into our area, it was about midday on June 3rd. You can see in the right-hand corner there the storm reports across Pennsylvania and into New Jersey. And in the upper left there is the image of the radar loop as it moved through our area. You can see in this image, as I mentioned before, that the bowing can sometimes be an indication of severe straight line winds, and that is pretty apparent, especially as it gets right around here, as it gets closer to Philadelphia and into New Jersey, although it was severe well before then. In fact, some of the highest wind gusts were recorded in Berks County when it moved through there earlier. So when we get reports of damage and there is a question as to if it was tornado or straight line wind damage. We may do what is called a storm survey. And so there's some things that we would be looking for. Number one, we'll look for the degree of damage. See if we can get an estimate of the strongest winds. And the second thing is to determine if it was caused due to tornado or to straight line wind. So here's an example of some of the things we look at. In the left-hand side here, this is an example from October 16th, 2018. If you remember several slides ago when I showed you the image of the tornado, this was actually the starting point of the Monroe County tornado that day. And you can see it's a very narrow swath. Unfortunately, fortunately, it happened over a very rural area. And it was basically in a state forest, no roads anywhere near. So this is actually taken from a plane, and you can see where it started. Very narrow swath. The trees outside of that swath are virtually untouched. And so that can be one indication of tornadic damage. Another indication, it's kind of hard to see from this image because it is so far away, but oftentimes the debris will be laying in a chaotic manner. It will not be laying in the same direction. It will be, trees will be, debris from the damage will be laying in various different directions, and it'll be a very chaotic debris path. Compare that with on the right-hand side here. This is tree damage following a downburst, specifically a microburst. And as I mentioned before, the downburst, you tend to see a fanning out. So you can see from the middle line here that I'm drawing with my pointer, the trees are laying out from this middle line. That's an indication that the middle line was where the center of the downburst was, and trees are fanned out from there. Here's another example where you have one house that has significant damage, and the house right next to it has very little damage. This very narrow path is indicative of tornadic damage. This was caused by a tornado. Compare that with this. This was caused by straight line winds, and the determining factor of that was that the debris is all laying out in the same direction. It's almost like somebody came through and just pushed that portion of the building in one direction. And so that's indicative of straight line wind damage. One thing to note when we talk about tornadoes and straight line wind damage is that they don't happen in a vacuum, and quite frequently when you have tornadoes, you will also have straight line wind damage nearby. This is often due to something known as the rear flank downdraft. That's a region of dry air sinking on the backside of a rotating thunderstorm. We had an example earlier this year, from August 7th, 2020. This is in Newcastle County. And I know that it's hard to see kind of with the what the scale is on this, but this road here is I-95 as it goes around the northwest side of Wilmington. The area outlined in green is the path of a tornado that was in EF1. But you can see we had all these little green dots down here. Those were all locations that experienced damage. So we had quite a bit more damage, but it was actually all that damage to the south was done by straight line winds and occurred over a much larger area than the initial path of the tornado. So again, straight line winds can do just as much, if not more damage than a tornado. We want to emphasize that because we want people to take severe thunderstorm warnings serious as well as tornado warnings. The tendency is for people to think, well, if it's not a tornado, it's not going to be that bad. But we want to emphasize that that severe thunderstorms can do just as much damage, if not more than the tornadoes. Switching gears again, now we're going to be talking about hail. Here's an example, again, from this year. This was July 1st in Cape May County. You had hail up to the size of $50. And you can see this example. It had so much hail, it almost looked like the ground was covered with snow, but it wasn't. That was the beginning of July. That was all hail. So how does hail develop? Well, it forms in the updraft. Once air travels above the freezing level, above where it is 32 degrees Fahrenheit, 0 degrees Celsius, the ice that is in that layer will start collecting any liquid water that's still around. As it does, it grows. Eventually, it's going to become too large for the updraft to keep it lofted, and so it will eventually fall to the ground. Typically, in the downdraft, it will get lofted over into the downdraft, but sometimes it can fall within the updraft area if it's just too large for the updraft to keep it lofted. Very large hail, that's baseball size or larger, can fall at speeds of 100 miles per hour or more. I throw this fact in here because it really drives home how dangerous hail is. It does cause more than $1 billion in damage to property and crops every year, and the speed that is coming out of the storm is related to its size. So as you can imagine, by the time it gets up to the size of a baseball, it's coming out of that storm at 100 miles per hour. When we describe hail, when you report hail, we want you to describe it in terms of, first of all, coins, and then if it gets too big for coins, then we want you to describe it in terms of sports. So commonly around here, first starts off with pea size, and then you may see hail size of pennies, nickels, quarters, or $50. And then once it gets above that, then we're looking at sports, starting with ping pong ball, golf ball, and going on up. We do that because it's a lot easier for you to picture in your mind how the hail might look in relationship to a common object than trying to guesstimate the size. If you can measure it safely after the hail has stopped, if you can measure it, that's great. But if you can't, if you can just kind of visualize how it would look in terms of either coins or sports, we would appreciate it. And if you can give us a picture, especially if you can give us a picture with a reference point, either coins or a golf ball, as you can see there, that is wonderful. I mentioned this briefly earlier. All thunderstorms are hazardous because by definition, all thunderstorms have lightning. However, lightning is not a criterion for severe thunderstorms. You notice when we talked about the three things that make storms severe: large hail, strong winds, or a tornado, lightning was not mentioned there. But it is still, even though it's not a criterion for severe thunderstorms, it is still important to take precautions in staying safe against this hazard. Lightning can strike 10 to 20 miles away from the main core of the storm, including in areas where it isn't currently raining. Unfortunately, last year, 2019, we had a case in our area where two gentlemen were outside. It was not raining where they were. They were about 7 miles away from the main core of the thunderstorm and were injured when lightning struck. So if you are close enough to hear thunder, you are close enough to be struck by lightning. So So what do we want you to report when you are reporting thunderstorms? If you experience wind gusts of 40 miles per hour or greater, if you can estimate that speed, or if you have weather equipment is not required to be a storm spotter, but if you have that equipment and it measures a gust of 40 miles per hour or greater, we appreciate those reports. Hail of any size, but especially hail that is penny-sized and larger. You see any damage, be it trees, power lines down, structural damage, we appreciate those reports. Obviously, if you see a tornado or a funnel cloud, those are important reports for us to get and as close to real time as possible. If you see a wall cloud, you can report that. Again, a lot of thunderstorms have wall clouds and that are not severe. So we appreciate the report, but just because of the presence of a wall cloud doesn't necessarily mean the storm is severe. And if, heaven forbid, there are any lightning-related injury, fatalities, or damage, we appreciate those reports as well. There are some things that you don't need to report. We would prefer you didn't report because of the workload involved with sorting through all the reports that we receive, especially during busy weather events. Please do not report radar signatures. If your radar app is showing a TVS or a hook echo, it's great that you're looking at it, but we also have access to that radar data, so you do not need to report that, and you do not need to report lightning itself, even if it's really frequent lightning, unless it causes injury, fatality, or damage. We don't need to have reports of lightning itself. Switching gears again, now we're going to talk about flash flooding. Flash flooding is the #1 severe weather-related killer, more than tornadoes, more than lightning, and more than hurricanes. A majority of flash flood fatalities happen in vehicles. People think that the water over the road doesn't look that deep, or think they can make it in there, especially if they have an SUV. And unfortunately, too often vehicles are picked up by the water, and they lose control on the roadway. Even if the water doesn't look very deep, the road could be washed out underneath. Here is an example, also from this year, from Gloucester County, New Jersey. This was in the aftermath of the heavy rain on August 7th. So this was the same storm that produced the EF1 tornado near Wilmington that we were talking about earlier, with also the damage in the rear flank downdraft. It also caused heavy rain as it moved into South Jersey. We didn't have any reports of a tornado by that point, but still was causing very heavy rain and flooding. And so this was a case where the road actually got washed out due to that heavy rain. And as you might imagine, when the water, it's easy to tell in this image that the road has been washed out. But if you're in the middle of the event, like in the case of this image, it's hard to tell if that road is still intact when you can't see it because of the water. Flash flooding is defined as a rapid rise of water levels to flooding conditions that happens within 6 hours of the causative event. In most cases, that's heavy rain. So basically, it's just flooding that happens within 6 hours of the rainfall that occurred. But there are other causes for flash flooding. Ice jams. If rivers are iced over, the ice starts to break apart, or some water is trying to get through the ice, it starts to back up. It's not the most common around here, but it has happened in the past. We've had cases of ice jam flooding on the Delaware River near Trenton in years past. Obviously, this occurs primarily in the winter months. And if there is dam failures, we have several dams in the area. If, heaven forbid, there is ever a dam failure, obviously downstream of the dam can experience flash flooding. One thing to note is that flash flooding can occur in downstream areas miles away from where the heavy rain actually occurred. There was a tragic case from the 1970s in Colorado called the Big Thompson flood that had over 100 fatalities. It was a case where heavy rain fell far up the canyon, and that wave of water was coming down the canyon. Further downstream, people further downstream hadn't seen any rain, so didn't think there was a threat, and unfortunately that resulted in several dozen fatalities. Again, that was back in the 1970s in the Big Thompson Canyon in Colorado. We talked a little bit about how majority of fatalities occur when people are in cars, and people tend to underestimate how much water it can take to float away most passenger vehicles. First of all, for a person outside of a vehicle, it only takes about 6 inches of fast-moving water that can knock over and carry away an adult. For smaller cars, it can take as little as a foot of fast-moving water to carry away a car. And if you think you have a lot more protection if you're in an SUV or a truck, you don't. It only takes a minimum of 18 inches of fast-moving water to carry away even larger passenger vehicles. So what can you report with flash flooding? Any flooding that results in evacuations, any water that is rapidly rising or entering homes and businesses, water rescues, from if there's water rescues of people in cars, water rescues of people on roofs, or people clinging to trees. Roads impassable or closed due to high water. And by this we mean roads that aren't usually closed in heavy rain. We have a lot of roads in the area that tend to close with just a little bit of heavy rain. So we're looking for roads that are not your usual spots that might be closed due to high water. Streams or rivers overflowing their banks, greater than 1 inch of rainfall in 1 hour. Switching gears again, now we're going to be talking about tropical cyclones. And I'm using the term tropical cyclone because this is going to be covering any kind of tropical system, be it a tropical depression, tropical storm, or a hurricane. That's kind of an umbrella term we use to describe all of those. So here is the climatology of the hurricane season in the Atlantic. This is on average, every season is different. And one thing we like to emphasize is that even in slow year, it only takes one hurricane to make landfall in a populated area to cause the season to become a bad season in terms of damage and impacts to us. So, but for the Atlantic tropical season, we typically see our peak in mid-September. And it officially lasts from June 1st to November 30th, but we have seen tropical systems outside of the season. It is uncommon, but not unprecedented. Tropical systems can bring a wide variety of hazards. What a lot of people don't realize is that many people focus on what the category of the hurricane is, or if it's a hurricane versus a tropical storm. But those distinctions are only defined by one hazard, and that is damaging winds. Those distinctions are not telling you anything about the other hazards that could come with tropical cyclones. So, for example, storm surge flooding, or sometimes called tidal flooding, saltwater flooding, freshwater flooding, again, damaging wind, tornadoes, and damaging waves and rip currents. So within our area, I just have a few examples of some of the storms that have brought all of these hazards to our region. Storm surge flooding, of course, that was probably the most famous example was from Sandy in 2012. Freshwater flooding, we have a recent example of this. Isaias, which came into our region on August 4th of this year, had numerous reports of flash flooding around the area due to the heavy rainfall. We also had an example from 2011 when Irene came through. Damaging wind, again, we had some examples of this with Isaias, but also with Gloria in 1985. Tornadoes, we had Ivan in 2004, brought some tornadoes to our area. Isaias, again, brought tornadoes to our area. We'll talk more about that here in a little bit. Some examples of some storms that have brought damaging winds and high risk of rip currents, both Jose and Maria back in 2017. But the rip current risk is actually quite common in our area. That can happen with a storm that doesn't even get anywhere close to our region. Even if it just stays well offshore, we can get damaging waves and rip currents as a result of it. So again, Isaias, it was a tropical storm by the time it got into our area. Again, the impacts in our area occurred on August 4th of 2020. As I mentioned, it brought quite a few tornadoes in our region, 8 tornadoes just on that day alone. 3 occurred in Delaware. In fact, one of those in Delaware was the longest track tornado for the state of Delaware. Preliminarily, we're still reviewing the records. It brought 1 tornado in northeastern Maryland, 2 in southeastern Pennsylvania, and 2 in South Jersey. There were several reports of flash flooding, as I mentioned, and you can see in the bottom right there, that is the rain totals that were reported across the region, anywhere from less than an inch right along the coast to, in some cases, over 8 inches as you got further inland. The peak wind gust that was measured was 109 miles per hour near Long Beach Island. However, we think this wind gust was actually measured during a water spout, so that's not really indicative of the larger scale wind fields. Most areas had peak wind gusts between 50 and 70 miles per hour. We'll take a look back at what a year this has been so far. All of this data is up to date as of October 1st. We have issued 292 severe thunderstorm warnings. That is well above normal. In fact, we are third most for any given year, behind 2019, which last year was a very active severe weather year. We had 410 warnings that year. And 2011, we had 307 warnings, so we're just slightly behind 2011. We have issued 32 tornado warnings, a lot of those coming the day that Isaias came through. That is tied with 2019 for the most tornado warnings in a single year. We have confirmed of the warning. Of course, not every time we issue a warning a tornado occurs, but we have had 13 tornadoes. Again, 8 of those 13 were associated with Isaias. We have issued 65 flash flood warnings. That's above average, but still far below the 113 that were issued in 2018, which was a very active year for flash flooding. So some notable events, we've talked a little bit about these, but June 3rd was the derecho. As I mentioned, we showed that radar loop several slides ago. It was followed within a few hours by more severe thunderstorms. It wasn't a second derecho, but it was more isolated severe thunderstorms later that same day. On July 6th, we had widespread severe thunderstorms across the region. Had severe flash flooding in Philadelphia, Morristown, and Reading. And again, we've already talked quite a bit about this, but on August 4th, Tropical Storm Isaias brought several hazards to our area. Shifting gears again, now we're going to talk about winter weather. And I put in the yearly review ahead of this because so far 2020 hasn't been all that interesting for those that like winter weather. We had a relatively quiet winter from 2019 into 2020. So first we'll define the different types of winter precip that we talk about. Starting on the right-hand side of this graphic, snow, that is precipitation that falls as frozen from the cloud base all the way down to the ground. It doesn't have a chance to melt. It stays frozen all the way down to the ground. Sleet, that is typically a precip that has started off as snow or ice crystals in the cloud. It encounters a warm layer somewhere above the surface where it melts, either totally or partially melts, but then gets into another layer that is below freezing before it reaches the ground, so it's able to refreeze into tiny spheres. Freezing rain is a similar process as to sleet. However, in this case, the layer of cold air that's near the surface is not deep enough for those raindrops to refreeze, so it falls as liquid water until it hits a surface that is below freezing, and of course can be very dangerous for ice accretion. And then rain too occurs typically in the wintertime. Any precipitation developing in the clouds is typically developing as frozen precipitation, but it'll just encounter a very deep warm layer that extends all the way down to the ground, which means it will have a chance to either partially or totally melt falling as rain. When we're talking about winter weather, here are some common winter weather terms. Coastal storms, these are storms that kind of hug the coast. These types of storms typically result in multiple precipitation types over our region. Not always, but these are commonly the storms that will bring us mixed precip or rain changing to snow, any kind of complicated precipitation pattern. And can also bring other hazards. In addition to wintry precip, it can bring hazards including coastal flooding if the onshore flow is strong enough. A subset of this is nor'easters. Officially, a definition of a nor'easter is a northeastern wind, particularly strong wind or gale. But commonly in our area, it is also used to talk about coastal storms which bring northeasterly winds. Another type of winter weather storm that we can get is called a clipper system, or sometimes called an Alberta clipper. This is a low pressure system that is often very fast moving and typically originates in Western Canada, near or over the province of Alberta. That's how it gets the name Alberta clipper. It is typically does not have as much moisture as a coastal storm because it is originating from the interior of the continent. This, for our area, what this typically means, if it's cold enough, is that it's most often just snow. We don't see as often with clipper systems the complicated precipitation type, if there's a mix or if it's changing. Typically when this comes through in the middle of winter, we're looking at an all snow. But because of its low moisture content and because it is typically quite progressive, it does not necessarily result in more snow than what you would see with a coastal storm. So more common winter weather terms. Snow squalls, we'll be talking more about this in just a minute, but these are intense but limited durations of moderate to heavy snowfall, often accompanied by gusty winds, resulting in reduced visibility, can be near whiteout conditions that don't last for very long. A blizzard, a lot of people think that any storm that just dumps a lot of snow must be a blizzard, but a blizzard actually has a very defined criteria that's more than just snow. A blizzard, in order for a winter storm to be a blizzard, it has to have winds, either sustained or frequent gusts of 35 miles per hour or more. It has to have falling and or blowing snow. And notice with the or there, it doesn't necessarily mean that snow has to be falling. In fact, I used to live in North Dakota, and we would have frequently what we call ground blizzards, whereas you reach all the criteria for a blizzard, except snow isn't falling, but you have snow already on the ground that is being blown around. And the strong winds combined with either snow already on the ground or snow falling will result in visibility of 1/4 mile or less. And this has to have a duration of 3 hours or more. So it's relatively uncommon phenomenon for our area, though not completely unheard of. Far more common in the upper Midwest. So snow squall, as I promised before, we'll be talking more about that. You may have noticed in the last few years, the last 2 years specifically, you started to get alerts on your phone for snow squall warnings. This is a relatively new warning. Again, we've just been issuing it for the past 2 years. The reason that it does alert on your phone, like tornado warnings and some flash flood warnings, is that these can be particularly hazardous for drivers. Snow squalls have been responsible for multi-car pileups on interstates. Several years ago, unfortunately, there was a multi-car pileup on the PA Turnpike due to a snow squall because they result in reduced visibility over a very short period of time in a very short distance and suddenly very slick conditions. Even though snow squalls typically don't amount to a considerable amount of snow accumulations, even just a little bit can result in very slick roadways. Here's an example. I'm going to play this video now from January 8th of this year. This is an example, as you can probably see from the view of Philadelphia. You can see Independence Hall here in the foreground. And again, this was a snow squall on January 8th. You can see starting off quite bright and sunny. Obviously the speed of this video is sped up, but in general it took, we went from sunny conditions to near whiteout conditions, as you're seeing now, over the course of about 15 minutes. So it did not take long at all. You can see the visibility greatly reduced there. And once it passes, you can tell there hasn't been much snow accumulation. You can see, some of the grassy areas, you can still see a little bit of green there. But during the height of the snow squall, very reduced visibilities, and again, you can have slick roadways. So how do you get an accurate snowfall measurement? I will be when I send you your spotter ID, if you choose to become a spotter, I will be sending out a spotter report information sheet, which will have more information on this. But just to go over it quickly, typically, to get an accurate snowfall measurement, it's ideally measured on a flat, hard surface. The ideal surface is a specially designed snowboard, but any kind of flat, hard surface that is at the ground level, away from tall objects, but still sheltered from the wind, it is officially measured to the nearest tenth of an inch. That differs from rainfall, which is measured to the nearest hundredth. How do you get ice measurement? Well, if the ice accretion is uneven, as in the example of this branch here, you measure the ice accretion on both sides of the branch and then get an average. So what would we like you to report with winter weather? If you are getting snow amounts that are greater than 1 inch in an hour, we appreciate those reports. Otherwise, you can wait to give us your snow report until the storm has ended. We get several snow reports throughout a storm, typically around here, and it can be hard if you're calling in your snow report every 2 hours or every 3 hours to make sure that we're getting the latest in there. So outside of the snow, outside of heavy snow falling at more than 1 inch per hour, it's okay if you just want to send us your storm total snowfall once the storm has ended. Anytime you get freezing rain or freezing drizzle, we appreciate that report. And any kind of ice accumulation, ice accretion that you get, we appreciate those reports. Because obviously it doesn't take much ice accretion to cause hazardous conditions. So even if you have just a trace of ice, and we appreciate it too if you include in your report if it's accumulating on the roadways versus just on elevated surfaces. So how to report. Again, I will be sending you, if you choose to become a Skywarn spotter, I will be sending you a spotter report information sheet with all of this information. So don't feel like you have to write all this down right away. You will get a sheet that has all this information. We prefer you to send in your reports either via email at the email address shown there, or if you are a ham radio operator, you have an active net controller in your area, you can use that to pass along your report. We also have Facebook and Twitter, so you're welcome to share your report over social media. If you do, however, please make sure to note in that report that you are a spotter, because we can get reports over social media from people that aren't spotters, and we just want to make sure that we signify your report as coming from a trained spotter. We also have a phone number if none of the above options are available to you. This phone number is restricted just for reporting weather. Please don't give it out to friends or post it online, as it is an unlisted number. And again, our preferred options are either email or through amateur radio net controllers, just because that makes it easier for us to have a written record of your report. When you are submitting a report, it's important to include your name, your spotter ID if you have it. If you're away from your home and you want to report something but you don't have your spotter ID, that's fine. Just report your name. And make sure you report your location. Even if you have your spotter ID, we want to just make sure you have your location in there so we know where the report is coming from. The type of weather that occurred, or the meat of the report, what you are reporting, and then what time this occurred. A lot of times it will not be safe to get the measurement of the hail size until after it has stopped falling. So especially for hail, if you want to wait until the storm has passed and then go out and measure it, the number one goal of the Skywarn program is to stay safe. We talked about this at the beginning, but your reports are used to help verify warnings or advisories that we have issued. Whenever we issue a warning, we want to know that what we warned for actually did occur. So we utilize those reports for that. It can help us to see if a warning or advisory may be needed if it's not already in effect. So if you're getting a thunderstorm and you're starting to get some hail that maybe is approaching quarter-size inch, it's important for us to know that, so we know that we may need to be watching that storm a little closer. It can help downstream residents that the storm may affect. And we can sometimes, depending on the reports and depending on how quickly we get it, we can include that in updates in the warnings and advisories to add credibility, and that typically enhances public response. If people hear in a, say, severe thunderstorm warning that strong winds are already occurring, then they're more likely to take action, to take shelter with the severe thunderstorm warning. If you have any questions about the Skywarn program, feel free to contact me. My email is up on the screen, sarah.johnson@noaa.gov. Again, that's sarah.johnson@noaa.gov. Thank you so much again for your interest in the Skywarn program. We sincerely appreciate it. If you have any questions, feel free to email me. And if you are interested now in becoming a spotter, please don't forget to register to become a spotter. The link for the registration form should have been sent to you along with the email with the link to this recording. Thank you again for your interest.